somehow change the way we collect data. Not necessarily big data is changing it, but because the data is growing, so obviously we need a better way to handle that. And also, think about yourself. You are big data because you're radiating all the data every day, every second. You have wearables, you have your mobile phones, IoT that Kevin's going to talk about today. A lot of the machine learning stuff is going to move from a macro level modeling to personalized modeling, and scalable logging system and stream processing will also become very, very popular. I think it also changed the way we approach a problem. Previously, when you want to do some qualitative analysis, today you have more data. Can you actually adopt a quantitative approach? Statistician is probably going to say, it's going to have sample bias, there are lots of issues. But if you know how to test and evaluate your model, sometimes it works fine. And do we focus on building the best algorithm? Do you spend like the next 3 months just to make your model more perfect, improve the performance by, I don't know, 1%? Or do you actually focus on integrating your solution into the product or do more A/B testing? That actually matters. And the tools we use for big data is also different. Previously we used SAS, Oracle. IBM has purchased SPSS, but they're all starting to support Spark, Hadoop solution. So they're evolving and they're building innovations on top of some of the open source solutions as well. And also changed the way we apply models. So previously it's all batch-oriented storing, but there are a lot of online learning and real-time storing happening. The way we build data science team are also different. So in the past, you probably have a team, then you have your statistician who only focus on building models, and then you have, once they build a model, probably going to send that to your server team or your software engineers, let them to implement the model. But I see that changing a little bit. The demand for data scientists, you probably have to know a lot of these things. So you probably need to think about, do you want to have some generalists on your team? And you probably also need specialists on your team. You're going to have a mix of those talents. And should I hire data scientists first or data engineer first? I think advice is always hire data engineers before you do data science. Again, applications of your algorithm have also changed. In the interest of time, I'll move on. This is a pretty typical big data architecture, not necessarily the best one. This is a talk given by a company. It's a Toronto-based company called Payton Lab. They do a lot of meetup and talks. This is the architecture they use. I think recently they got invested by Alibaba as well. But this is their architecture. They collect data using Kafka. Their reporting is still based on MySQL. They log all the raw logs into HDFS, which is Hadoop-based. So they also have NoSQL database such as HBase and Cassandra. Previously, all the modeling or machine learning stuff, big data crunching happens in batch mode. But today they also adopt Spark streaming for some of the real-time stuff. So this is more considered like a Lambda architecture, which is quite popular today. Talking a little bit about cloud. A lot of people are excited about cloud. There are some big players. Amazon Web Service, Microsoft, IBM is pushing really hard, and also Google Cloud Platform. Adyen is also, I think it's very, 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 well, you need to watch out for them because they move really fast. Their platform is also pretty good. Oracle, last week, they also announced that they're going to have big data in the cloud, moving some of the Oracle Exadata instance and other stuff into the cloud. So this is also something we need to watch out for. That Amazon Web Service is still the dominant player in this field right now. I would also pay more attention to Microsoft and also AWS. All right, so in AWS, because I recently started using AWS, I find it a pretty good platform, but this is a pretty standard architecture. They have their managed Hadoop cluster, so if I want to crunch some 500 terabytes of data, I'll probably just launch a 250 node Hadoop cluster on demand. So it takes 15 minutes to have a managed Hadoop cluster up and running, so you don't need an IT person. It's really easy to use. They have Prometheus for real-time streaming. They also have their own managed relational databases. They also support like Oracle, MySQL. They have their own version of MySQL, Aurora, which is five times faster than MySQL. Again, they have its own DynamoDB. Some people don't like it. They had an outage a few weeks ago. Yeah, they also EMR, Elastic MapReduce. This is Amazon's managed Hadoop cluster. They also support Apache Spark now. We talked about user profiling and online advertising. So this is, if you want to deploy that kind of ad serving, this is a standard architecture. I believe the slides is going to be shared with you guys, so you don't have to worry about taking photos. So this is the last part, lessons learned. I think it's more about the team doing data science. It's not about the unicorn because it's really hard for someone to actually know everything. So I think it's a teamwork. Unicorns are rare. Even if you can find them, sometimes it's hard to harness them. I had one guy on my team. He's actually my alumni. He's a brilliant guy. He won IBM mainframe competition, I think 3 years in a row. Beating like 4,000 other students from the US. He's a great software engineer, programmer. He was on my team only for 6 months because he felt like it wasn't very challenging. Once he learned something, he knows MapReduce, and it's really easy for him. He's looking for something more exciting. So then he moved on to Amazon, and then he ended up at Google. Now he's really satisfied. He's a good friend of mine. I always make fun of him. So find your place in the spectrum. We all come from different backgrounds. So we have IT personnel who are actually more suitable for DevOps role in data science, or we have architecture or engineers who actually can become a data engineer or a big data architect. If you come from a SaaS background or some statistician, you can be a data analyst or data scientist for sure. A lot of the great demand in the future are also for like the product manager or project managers who actually know big data. These are actually even like more scarce resource than data scientists. Not a lot of product managers can actually understand how to use big data, but if they do, it can be really, really powerful because they directly have impact on how to design your product. So you also need, as a data scientist, you also need to know how to communicate with them very well. I think I'm not the best Spark programmer, best MapReduce programmer. If you ask me how deep learning works, I probably will only tell you very superficial stuff that everybody can read in the news. But I think that a lot of good things I learned in the past is the problem-solving skills. So we cracked a lot of tough problems, and it's one thing that in your career that I think will become your asset because all the skills can be learned. As some of you, I listened to some of the talk by some of you before. We are all Chinese. We are all very smart. Learning, Spark, Hadoop, it's actually not hard at all for us. But how to use that to solve tough problems, that's the skill set I think that will become the great asset we have. And the way you approach the problem, the way you do research, the way you solve a problem will follow you just like, you'll never forget how to ride a bike, right? Once you learn how to do it. Some lessons learned building a data science team. So from 4 different perspectives, from a data engineering perspective, we had a tough beginning because we were SaaS users. We are not strong programmers, even though later on I have Kevin to help me. He did a lot of great work, but it was a tough beginning. I have to learn Java. I have to write MapReduce code for people you may know type of recommendation. Building data pipelines are quite complex. Sometimes it needs to be well architected. Each one of these are some kind of code or process you're running on, crunching your data, but chain these together in a data pipeline, it's actually quite complex. They need to handle a lot of the dependency very well, otherwise it will easily break down the system. DevOps is also very critical. Automation and productionization and monitoring is also very essential, running in a production system. Data scientists also need to learn how to manage your code and deployment. Some people always like use like Excel spreadsheet or like but you need to learn how to use GitHub anyway. And hire data engineers before you hire data scientists. And from a data science perspective, it's not just about the algorithm. As I said, don't get too obsessed with your algorithm. You need to know how to apply them and modularize your data science project. You probably are working on 5 different pieces. You don't want each person to jump all over to work on different things. You want them to get focused on that one component and become an expert. And later on, you can share the knowledge. Otherwise, it's going to be very messy. Models are useless if they cannot make into production system. This is what I learned over time. We have a software engineer team, server team. They just don't trust you because they think you guys don't even know how to program. Like, I know you can build models. You don't even know how to apply it. Do you know how to load it into a NoSQL database? How do you even make it work with your server system? So these are the hard lessons we learn. And data science team needs to self-serve, honestly. And this is actually the trend. So a lot of the data science team also have like DevOps roles that help them actually move things to production. And my suggestion is read extensive and widely. You need to read. There are new information coming out every day. Read more research, industrial, or conference papers than big data news. I know a lot of you read about data science or big data news, but try to read in more depth. Innovation idea may come from other areas as well. I think some of the most toughest problem I solved in the last few years is actually nothing to do with the big data paper or news I read. It's actually something I read, not directly related to my project, but then it becomes an inspiration. So I was working on a classification for mobile application and all the reviews and all the. I want to basically let's say we have 500,000 apps in App Store. I want to do classification, but I want to categorize all these apps. So I have all the app descriptions, but I don't have my label. So I cannot train my classifier. And then I was reading someone's blog and talking about Mechanical Turk, that humans can actually help you to do all the manual classification. That was a brilliant idea. So we did that. We classified 500,000 application and text just in 2 hours, and we were paid a couple of $100. And then we were able to have the label and build model. So sometimes you get inspired by some other random stuff. And this is so as a manager, from a manager's perspective, I have a master's degree. It's actually very challenging for me to manage PhDs because we all have egos. Sometimes you say, we should do this, but they disagree with you. So managing a team of PhDs who are actually better than you and smarter than you, more experienced than you, is hard. I have one of the, my team is pretty multinational. I have people from India, no, not India, from many different countries. So there's one PhD, he always say, yeah, I have 10 years of machine learning background. I think we should do this. This is something I learned over time. But sometimes he's right, sometimes I'm right. So I do think you need to respect your talents on the team. And micromanaging kills innovation. Sometimes I try to force my idea to them. That didn't work out. But sometimes if you let them just go away and do their things, they'll come back with some innovation. I think that's information. And a great data scientist is good at storytelling. So if you can't really tell a story about the stuff you do, because you're basically communicating with business people and product managers. So if you only know how to fit the large distribution model, they don't understand it. I report to Senior VP of Emerging Technology, so it's a little bit challenging for me at the beginning because I have to do presentations for a team of 30, 40 directors. It's kind of challenging, but over time I realized that you know much better than them. They are actually counting on you to do some great stuff for them. So you also need to become the visionary. You need to tell your boss, hey, this is what we need to do. Most of the time they don't understand what you're talking about, but they will trust you. Okay, they rely on you.